Okay, so we're doing an extra day of review. It's a long story about why the test isn't today, but we're going to do an extra day of review, and the test is tomorrow. That also gives you a chance. Thursday is my morning help day, which is tomorrow. So you could come in and get morning help if you wanted to. So if you're like scared about this test, come in. I can do some practice problems with you. That would be smart. For some of you that haven't pulled off an A yet in this class, try it. Come in the morning. I can do some practice problems with you. It might make the difference. All right, so we're going to prove this one's odd. How do you do a proof of that? Is that the f of g of x thing? No, that's proving that something's are inverses. F of g of x simplifies down. That's for inverses. Proving something's odd is where you stick in a negative x and you simplify it down. And let's see if you can do it. I'll pause for a second. Will you prove this thing is odd? Okay, so you stick a negative x in. The test could have been today, and I think everybody knew to stick negative x in it. And now you simplify it. That's the third thing. This negative here does not go away because when you put something to the fifth, it's like there's 5 negatives, and every 2 negatives cancel, but there'd be an extra negative. This would stay negative 11x to the fifth, and this negative would not go away because of the cube, but there's another negative with it, and the negative together make it plus 3x to the third. That's the simplify step. Nothing new there. Now, the new thing I'm telling everybody is that you have to show factoring out a -1 next. Obviously, this thing was not even. Let me make sure you get why. If it was even, this is the rule, that when you stick a negative x in, the function should come back again. Is this exactly the same as the function? No. So then it's not even. So then what I was telling you guys is, well, then it must be odd, and then you put the -1 right here, and then you judge whether this is odd. You can't just do that. You have to factor out the -1. All right, so if we factor a -1 out, that makes both signs the opposite of what they were. 11x to the fifth minus 3x to the third. And now the cool part is when you end, you can just say -1 f of x, and this really is f of x. Look, it actually matches exactly with what we started with, and then it makes it like a more neat, perfect proof. Okay? Do you think you can hang with that? Just got to factor a -1 out if they're odd. Is there any part of that you want me to talk over more? All right. So next thing I'd like to do with you is this. Would you agree that that blue function has a domain and a range? Trying to remember what the domain is. Remember, you could set this part greater or equal to 0. Or, hint, I'd make a sketch. Because the sketch will also tell you the range. If you sketch this thing, you'll be able to look at your sketch and go, oh yeah, the domain's this and the range is that. Then find, this is the universal symbol for the inverse, which on the test today you should have gone in knowing, oh yeah, that's switching x and y and solving. All right, I'm going to pause for a minute while you give this one a shot. Let's see how you would have done on this question. So first off, you should know that this is a square root graph that's been moved left 1. That means that that's the spot -1, 0. That tells you your domain and range. Domain is from left to right, and so it goes from -1 to infinity. We're doing an extra review day for the test. There was a lot of reasons, but the range of this thing is, the lowest it goes is 0, to the highest it goes is infinity. How many of you had your domain and range right? Okay. Now that you see how to sketch it, you should have known that was just the square root moved over 1? Okay. Now, inverse. You take the y and you turn it into an x, square root of y plus 1. You switch x and y around. Now we're going to square both sides. I'll do it in red. Squared, squared. X squared equals, and the squared and the square root take each other out, and it's just y plus 1. Then I subtract 1, subtract 1. X squared minus 1 equals y. Now, there is your inverse. Now, you might assume at that moment that I can look at its picture and I'll know its domain and range. But this is one of those where you can't. You have to take the domain and range from this. So your domain becomes the range down here, which was -1 to infinity. And your domain comes from the range up here. 0 to infinity. Do you get that? I even barely get that because I think you should be able to look at this and figure out its domain and range. But you can't because of how inverses work. You started with this function. You can't just act like that function never existed. You started with that function, so its domain and range, if you did them right, have to be reversed. So your new domain can exist. So like, you can't just say, well, if I put in -6, it works fine. No, you can't put in -6 in this function. So it's weird. You can't just trust this and get its domain and range. You have to get it from here. They have to reverse. Okay. So the next kind of question. I had a ton of question.
So the reason for that is because like the inverse of the function is defined as f negative 1 of f of x is equal to x. But if f of x fails, then you can't.
There you go. Yes, I like that way of saying it. If this fails before it can turn into this new function, then you can't have a domain and range for it. So you're right. It depends on what you started with. That's why it depends. You said that very well. All right, I do need to move on. Got a lot of problems to practice. This was one that a ton of kids I'll just say a ton of kids got wrong. X squared minus 3x minus 4 is a function. That's easy. And this other one's another function. We'll call it g of x. And it's just x minus 5. I couldn't believe how many people did not know how to do f times g of x. And I think it's because you're like, well, could I FOIL it? No, you can't use the FOIL rules for multiplying this. If you have to multiply this, you have to know how to distribute from a triple to a double. And this is one of those things that you have to know. It's one of those algebra basics. I always say to put them in parentheses. X squared minus 3x minus 4 times the other function, x minus 5. Notice, put it in parentheses. And then you have to learn how to do this, not as FOIL, because there's no first outside, inside, last. It doesn't work. Instead, you have to know that you're just distributing. You can either distribute this way, or you could distribute where you distribute the -4 to both parts. Like here, I'll do it with a highlighter. I could do like this to that and this to that, and then distribute each of them that way. But you'll get the same exact answer. And there's a total of 6 parts, and then some like terms combined. I get a lot of algebra. Give it your best shot. This is really good practice. I'm afraid some of you would have made a lot of algebra mistakes on this test. So with an extra day of review, hopefully we'll have less retakes. I'm going to pause while you multiply this all out, and then in a moment you'll compare with the kid next to you. Okay, so after you multiplied them all out, let's see, Jack, I'm going to ask you to tell us what you think the final answer is. Starts with x to the third.
X to the third minus 8x squared.
Wait, x to the third minus 8x squared. Keep going.
Plus 11x plus 20.
Anybody verify because you got the same exact thing? Yeah. Okay. If you messed up, try to figure out where you messed up. It'd be very easy to mess up. Maybe you messed up in your multiplying, or maybe you messed up in combining like terms. All right. Okay, so next, and the last thing I want to practice with you, before I just give you a practice version of the 5 most important problems that I think you should know for the test. Last thing I want to practice is proving 2 things are inverses, because if you don't show the work right on this, you can't get the credit. So if I get 3x minus 9 as a function, and I get this other function of x plus 9 over 3, I think that they're inverses. But there's only one way to prove it. You got to take f of g of x and g of f of x, and showing your work very thoroughly, show that they both equal x. I'm going to pause for a second while you prove that these are inverses of each other. All right, here's how you'd prove this. You have to do f of g of x, and I know some of you are like, I know, but did you show the work right? Here's what the f function looks like with a parentheses where the x is, and then you drop in this one, and I'm going to change colors to match it, x plus 9 over 3, and did you then cancel just the 3? If you did this, listen, if you did this, I get it, you think you just showed me that the answer is x. I cannot accept that for credit. You have to show what order you did it in. So you can only cancel off one thing, like that. And then you can say, it simplifies to this. And then you can say the answer is x. What if you canceled the plus 9 and minus 9 first? You're wrong. That's not how that works. This one doesn't have a denominator and this one does. They could not be subtracted first. You'd have to cancel the 3 and the other 3 first. All right. Next, we have to go reverse. G of f of x, and here's g, empty spot plus 9 over 3 is stick in the other one, 3x minus 9, and then hopefully you know that you have to do the top part of the fraction first, and those 9's cancel, and it simplifies to 3x over 3, which simplifies to x. That is a proof that these 2 things are inverses. Okay, now I've just given out a worksheet with 5 problems on it that I made this morning once I realized that the test had some issues with not printing the right things and stuff. So this is now your homework for tonight, which is going to be really good practice for the test. Now please don't just act like, oh, it's another worksheet. Take it like a test, like right now. Act like you only have the rest of the hour to finish it. Then your only thing you'd have to do at home would be to check it against the key. I'll post a key, and then you can check it against that key. All right. So that's all I have for you for the video for today.